Well, it's the third day of limiting reagents, and we might as well just get right to it. These are the troll problems because there's a little bit more going on. Instead of just figuring out what the limiting reagent is, or then using the limiting reagent to predict how much of a product you're going to get, these problems ask if all of the limiting reagent is used up, how much excess is left over. So if we use my sandwich analogy, right, where we have 6 pieces of cheese and we have 20 slices of bread, we could probably do in our head how many sandwiches we could make. Well, if 1 cheese equals 1 sandwich, the most we can make is 6 sandwiches, which requires 12 pieces of bread, which means we have 8 slices of bread left over. Now, that is the gist of how we're going to be tackling these problems. We're going to figure out how many moles of limiting there are, and then if all of those moles are used up, how many moles of excess are used, and then we're going to figure out the mass and then subtract from the starting mass. And in a nutshell, that's what the problems are. I'm just going to grab my calculator. So here's the first problem. We got some magnesium reacting with hydrochloric acid, and it wants the mass left over. So to start with, it's going to be exactly like the last lesson. Balanced reaction. Find your limiting by using moles, and then we're going to take those limiting moles and use them to determine how many moles of excess were used, and then from that, how much mass of excess was used, and then subtract it. So it's going to take a couple times. I'm going to show you 2 problems. They're kind of time consuming. And then you'll be given some time to work on the assignment. You could start this week or you can work on it next week. Okay, so here's that same problem. Now, just to speed things up, I've already written out the reaction and balanced it. And it wants mass excess left over. So I've already done the first step, balanced reaction. Second step, I've written the molar masses. Now I need to find the moles of each of these substances. And we're going to be using that shortcut. And the formula is number of moles is mass over molar mass. Big M is molar mass. So 4 divided by 24.31 gets me 0.1645 mole. And that's obviously, there's more to that on my calculator. 3.5 divided by 36.46 gets me 0.09599 mole. Okay. Now, I hope we can all agree that if I took this and divided it by 2, and I took this and divided by 1, this will be my limiting reagent. I will have a smaller number of moles. Okay. So that means that's the limiting, and once you find the limiting, you know the excess. Now the next part to this is a little bit tricky. What we have to do is take these moles, the moles of the limiting, and use the mole ratio to figure out how many moles of excess were used. Remember, all of the moles of the limiting are going to get used up. So we have to figure out how many moles of excess are also going to be used up, but we'll have some moles left over. So what I'm going to do is I'm going to use that number, and this is the unrounded number on my calculator. Oh, let me just start writing that again. I was in my own shadow. It's kind of weird writing like this. 0.095995 mole hydrochloric acid, and I'm going to times that by the mole ratio between the two. So there are 2 moles of hydrochloric acid for every 1 mole of magnesium. Okay, so this is the first new step, and that's taking the limiting moles and timesing it by the mole ratio, right? So in effect, I'm dividing it by 2. So that's what I have to do, divide it by 2. And it's not times by 2, divide by 2. And I get 0.04799 mole, and this is hydrochloric acid. Okay. Now the second step is I have to find the mass of hydrochloric acid that was used. So I'm going to use the mole of magnesium. My bad, because these cancel. Backtrack, that's magnesium. Okay, so the second step is I'm going to take those moles, 0.04799 mole of magnesium, and I'm going to times that by the molar mass of magnesium, 24.31 grams per mole. That's mole magnesium, grams magnesium. And that gives me grams used. So timesing that by 24.31, I get 1.17. Now, you could round here, or you could use the unrounded out number, but what that tells me is that if I used all of the hydrochloric acid, I would use 1.17 grams of magnesium. And if we look, we actually have 4 grams of magnesium. So the third step is to take that and subtract it. 4 subtract. Okay, I get 2.83 grams. So that is the mass left over. So there's 3 steps that go into finding mass left over, and you need to understand how you get to the limiting, and you need to use the moles of the limiting, times it by the mole ratio, and then take those moles, times it by the molar mass of the excess, and then subtract from the starting mass of the excess. In a way, it's like finding out the sandwiches. I took the limiting amounts of cheese, I figured out how many sandwiches I could make or how much bread I would use. That's kind of this step here. And then I said, oh, I have used this much bread. I have this much bread total. How many pieces of bread do I have left over? In a way, it's about the same. In another way, it's not the same at all. Okay, all right. So let's try one more problem this way. So we've got iron chloride, and it's combining with sodium hydroxide. What's the limiting reagent, and how much excess is left over? So I'm going to do the exact same steps with a new problem. Okay, first, and I've already got the balanced reaction. I've got the molar masses. First step is to find the number of moles. So mass divided by molar mass. I get here 0.1325, and 21.5 divided by 40. I get 0.5375. Okay, now I'm pretty sure if I was to divide this by 2 and this by 1, what do you think the smallest number of moles will be? It's going to be this one, right? This is going to be around 0.2, and that's going to be a bigger number. So that is my limiting reagent. Okay, so now I'm going to take this. I'm going to go 0.1325 and use the whole number on my 96, okay, everything on my calculators, mole iron chloride. And I'm going to times it by the mole ratio. So there is 1 mole of iron chloride for every 2 moles of sodium, right? That's the balanced coefficients right there, okay? That cancels. Then I'm going to times that by the molar mass of the excess, right? Because this is the excess reagent. So 40 grams sodium hydroxide over mole sodium hydroxide. So moles cancel. Now that gives me the mass of sodium hydroxide that we used. 0.132596 times 2 times 40. And I wind up with 10.6 grams sodium hydroxide. Okay? This is the total amount of sodium hydroxide used. So my last step is to subtract the 2. 21.5 subtract 10.6. And I get 10.9, roughly. So let me try that again. I think I pressed the wrong button. No, it's 10.9. That is the amount that's left over. So I took the moles of the limiting, and then I times it by the ratio, so the moles of the limiting cancel out, and I'll be left with moles of excess. and then I times it by the molar mass of the excess, so the moles will cancel. Then I'm left with mass of excess used. So if I used all of the iron chloride, I would only need 10.6 grams of sodium hydroxide. Now you can see I combined the step here. See how we did that in 2 steps? I just snuck this step in here to save space. Now, you will get a problem on, like the problems that you guys are going to be working are on limiting reagents and acid-base curves, which we're covering next week. And there are 3 different limiting reagent problems. An easy one, which is mole to mole. A little bit tougher, finding the mass of something from 2 different substances and mass left over. So you might have to revisit these lessons. But that's limiting reagents. And we're actually done. That's all there is to do with limiting reagents. And we'll be practicing them next week in that assignment you're going to hand in. Alrighty.